Hi, my name is Yves Fauser. In this short demo video, I want to show you the integration of Pivotal Application Service with VMware NSX-T. Pivotal Application Service is also formerly known as the Elastic Runtime. So let's talk about the install experience first. What I will do as an operator is I will use Ops Manager to deploy both the application services and the NSX-T integration. So we have an additional tile that installs the integration with NSX-T, where you give a couple of informations like how to reach the NSX-T manager and authentication details like credentials and some of the integration details. Okay, before we go into the demo, let me talk a bit about what we will see. So the first thing that we decided to do is to give each of the orgs, which is a tenancy construct inside of Cloud Foundry, a network topology, and with that, a network identity. So if I create a new org, a virtual router will be created automatically. That virtual router will have one or more logical switches attached to it. And from NSX-T's IPAM, we will allocate a subnet or more to each of those orgs and configure that on the virtual router. What that means is that now every org can be identified in backend firewall systems or database systems that are upstream to the environment by a specific IP subnet or alternatively a sourcenet IP. So if we use NAT, we can assign a specific sourcenet IP to each of those orgs to save on precious IP space. Every application instance will have a logical port on one of those logical switches, and those logical ports of the application instance, so the container, has the same capabilities as a VM interface. So we have all sets of counters, we have our firewall attached to each of the container interfaces. We apply additional security by using SpoofGuard, using a specific IP address for each of the application instance that we enforce. So if an attacker would change its IP address in the application instance to spoof its identity, we would prevent the traffic from going through. We can also expose flow records. We can do remote mirroring sessions for troubleshooting purposes. Again, everything that you can do on a VM interface, you can now also do on a container interface. Okay, so let's go through the demo. And in the demo, you will see we have what an operator will see and what a user will see. So as a user, I'm using the CF CLI. And here I'm creating a new org. Well, first of all, let's review what orgs we have. We only have the system org. And we'll create a new org, which is cats and dogs. And this is purely creating this tenancy construct. Nothing yet will happen on NSX-T. Then I target the org through the CF CLI. I have to also create a space, which is a second tier tenancy construct in Cloud Foundry. And then I'll target that space. So now we'll change into a directory that contains my front-end code, which is my front-end app that we will access later. And I do a CF push, which pushes the application to Cloud Foundry. Now, if we look at switching here, you see that we right now have a couple of infrastructure logical switches, one existing logical switch for the system, but not yet the cats and dogs. But as soon as we have the build container starting, which is happening now, we will create the topology in NSX-T. So you now see the cats and dogs logical switch. This build container will also have an interface on the logical switch alongside with the interface of the router. And we can already look into the details here that we are in the staging phase of that build and that build container will now pull some code and create the actual app instance container, which it already did. So here you see destroying container, which means the build container was destroyed, and then it created the app instance container. So if I refresh here, then my build container is gone, but I now have my front-end container. Before we go into the details of that front-end logical port, let's already push the back-end application because, as you saw, it takes a while for the build container to create what we call droplet. So now let's go into the front end. And here you see we copy a lot of metadata that we get from Cloud Foundry onto the logical port that can then be used to match on firewall rules. We see that it's in a running phase, we see what space it is in, etc., etc. If we look at monitor, then we can see that we get all the counters of that interface. In manage, you can see things like port mirroring, spoof guard, etc. So it's a port just like a VM port. Let's have a look at the routing part. And here you can see that we have our cats and dogs logical router. That cats and dogs logical router has a specific router port that got an IP address assigned and is connected to that cats and dogs logical switch. And now if we look at our IPAM, we can see that the IP subnet for that logical router came out of a block of IP addresses, and we allocated a specific subnet to that topology. Now this subnet, or alternatively a specific IP address for netting, can be used to match in backend firewall systems. Now it's important to understand that all that you see here is more or less the operator experience, while what you see here is the user experience. So from a user experience, there is nothing to do on NSX-T itself. It's all automatically created for you. Okay, so now we also have the backend. So let's try to access the front end first, which is a simple front end app that I can use to try reachability on the backend apps. So I will just give the IP address of my backend container here and then try to access a simple website from the backend, and that will then be displayed here. So I can also access the backend, and here we see the IP address for that backend container is displayed, and it's saying that it's serving cats on the port 7007 to 7009. So let's try to access that. And you will see that it won't work. We will only see a dog and not a nice picture of a cat, simply because the request failed. And that's because by default, inside of the org, we don't allow container-to-container traffic. So if you look at NSX-T and look at the firewall here, there is a default firewall rule for the environment for the cats and dogs org that says, okay, from the external side, so from the Go routers to containers itself, allow the traffic. So that's why we can access the front end and the back end from external. But there is a default deny rule that drops all other traffic. And so container to container traffic directly on that same logical switch is currently prohibited. So what we do to allow it is we could obviously add firewall rules manually to the NSX UI. So as an operator, I could open up the ports or open up traffic using those metadata that I have on the logical ports. Or I can use the network policy CLI to do so. So as a user here, I can add a network policy if I have the rights to do so. And here I'm adding a network policy saying from the front end to the back end on TCP port 7007, allow the network communication. Once that is pushed, I can refresh my firewall rule set here, and you will see there will be an additional rule added to the top of the rule set that allows the traffic from the front end to the back end. Here it is. So we have the rule called TCP 7007. The source is a dynamically matching group that matches logical ports of that front-end application instance. The destination is a dynamically matching group that matches all logical ports of the backend, and it's allowing TCP traffic on port 7007. Okay, and then let's try to access our app again. Yeah, and here we have the picture of our happy cat. And finally, we can scale the environment a bit more, just add some more application instances. That is faster than what we saw before because there is no build phase. Okay, let's go to the logical switch again. And here we go. And those will flip to be up in a little while. It takes a while for the status to flip, but the connectivity is actually already there. And here we go. Those ports are up. Thanks for watching. I hope you enjoyed this short demo video. Watch out for more content to come soon that give you even more details on what we are doing between Cloud Foundry and NSX-T.